Okay, this is example 3 from page 8 in the packet. And what we're going to do is we're going to look at how we can use a word problem to find the constant of proportionality and then use that constant of proportionality to write an equation in the form y equals kx. So let's look at the Smiths going to the movies. So the Smiths are going to the movies and they bought 4 tickets for $33. What is the cost per ticket? So we're going to find the unit rate as the cost per ticket. So to do that, I'm going to put the cost in the numerator, and in the denominator, I'm going to put the number of tickets. Then I'm going to find the cost for one ticket by multiplying the denominator by 1/4 or dividing by 4 to get down to 1, and then doing the same thing in the numerator, either multiplying by 1/4 or dividing by 4, and then $33 divided by 4 is $8.25 for one ticket. So that means the constant of proportionality, which is the same as the unit rate, would be, the constant of proportionality here would be 8.25. Now, when I set up my proportion as dollars over tickets, that in itself helped me decide which one was my x value and which one was my y. Because whatever goes in the numerator, that is your y variable, and whatever goes in the denominator, that is your x variable. So I've decided, by setting it up this way, that x is the number of tickets and y is the cost. So when I write my equation, y, the total cost, equals the cost per ticket, which is $8.25, times x, which is the number of tickets purchased. So I take the number of tickets I'm buying, I multiply that by 8.25, and that's going to give me the total cost. So now that I have that equation, I can use that to find the cost for any number of tickets, and I can also use that to find the number of tickets given any cost. So let's try that now here in the next part. They buy 7 tickets at the same movie theater. So you can kind of figure it out. I mean, you might just do like, well, 8.25 times 7, and then get your answer, and that's true. But let me show you how you can document that you're using the equation. So what I'm going to do is I'm going to rewrite the equation that I already wrote. Do it again. Okay. Then I'm going to substitute. This is a new word, substitute. So substitute means I'm going to replace the x with 7. So I'm going to do 8.25 times 7 equals y. So I recopied the y, I recopied the equal sign, I recopied the 8.25, and now I'm just substituting in 7 for the x. So I'm really doing the same math, I'm just writing it out a little differently. So 8.25, using the calculator, times 7, I get 57.75. And that's what my y equals. So in the end, the answer is it cost $57.75 for 7 movie tickets. And now I'm going to use the same equation that we have, y equals 8.25x. I'm going to use that equation to find the cost, find the number of tickets for $41.25. So this time when I do my substitution, I'm actually going to substitute in the $41.25 in for the y variable because that's where the cost goes. I'm going to recopy the equal sign, I'm recopying the 8.25, and I'm recopying the x. So now what it says is $41.25 equals 8.25 times something. So to find that something, I'm going to divide. So I'm going to divide both sides by the number I'm multiplying by, which is 8.25, the unit rate, and then I'll get what x equals. So when I divided, I got x equals 5. So that means they can buy 5 tickets for $41.25. And that makes sense because when they bought 4 tickets, it was $33. And if you add $8.25 to 33, you get $41.25. So 5 tickets make sense. It's one more ticket than when they had. So there's lots of ways of solving these problems. I'm just showing you how you can use the equation to solve them. So it's good to have more than one way. Okay, let's take a look at one more example before we end the video. So now we're going to talk about this fun fair park where the admission costs $20 to get in and each ride costs $5. So can you represent the total cost y for admissions and x rides at the amusement park using the equation in the form y equals kx? So this is kind of different than what we had before. We have some information. We have both of them being cost, but I want you to notice there's two different kinds of cost. There's the cost that would be to get in, the admission cost, and then there's the cost for each ride. So the cost for each ride means it's $5 per ride. Well, if you can hear it in the name, that's a unit rate. So $5 is the unit rate. So then what's the $20? Well, let's just think about this for a second. Let's just make a quick table, okay? So I'm going to draw a really quick table. And in my table, it tells me that cost is y, so that's going to be the money. It's going to go down here, $, and that the rides is x, because it says x rides, so that's going to be the number of rides. I try to write. And then I'm going to keep track of a few different things, and I'm going to leave a space here. So if I went on one ride, I would have to pay $20 to get in and $5 more to get on the ride. If I go on 2 rides, I would pay $20 to get in and $5 for each ride, so that would be a total of $30. Right? If I go on 3 rides, I'm paying $5 more than before, so that's $35. 4 rides would be $40. Okay, so I kind of have a table going. So now that I do that, I can see, oh, right here, it looks like I have a unit rate because there's my one. One ride is $25. But that's not the same as right here, right? Because doesn't it say the unit rate is $5? So how are they different? Well, they're different because this $25 includes the admission fee. So if I go to make unit rates from all of these things, 25 divided by 1 is 25, so $30 for 2 tickets, well, that's 15. And we'll jump to 4. $40 for 4 tickets. Well, now, stop doing that. Well, now that's $10. So none of these are actually, let's just say 15. None of these are actually $5 because I have to add the admission fee. So this is not proportional. It's not proportional because at the beginning, and I wish I could get there, but at the beginning, let's see, move this, there we go. Oh, went away, sorry. Remember how he left a space? This should say rides, I'm sorry. This is for 0 rides. Well, how much does 0 rides cost? Well, normally I would say $0, but in this case, even if you go to the amusement park, this amusement park in particular, if you go there at the Fun Fair amusement park and you just walk in but you don't go on any rides, you had to pay $20 to get in. So this isn't 0. In all of your other proportional tables, 0 will be 0. Like in the previous one, if you went to the movies but you buy 0 tickets, if you walk into the theater but you buy 0 tickets, you're going to pay $0. But in this one, you have an upfront charge. So that's why the unit rates weren't equal. So this is not proportional. And since this is not proportional, even though I'm writing proportional, but it's not picking it up. Anyway, this is not proportional. And since it's not proportional, I cannot write an equation in the form y equals kx. I could write an equation here, but it's not going to be in the form y equals kx. It's going to look a little different. So sometimes relationships are not proportional, so not all of them will fit this mold. So be looking for whether or not your equation is proportional whether or not your relationship is proportional, because if your relationship is proportional, you could find the constant and make the equation. Thanks for watching.